Don't forget to subscribe, like, comment, and share this video with your classmates.
Okay, let's jump right in. Picture this, it's sports day at school, things are kind of chaotic, and a certain robot is about to kick off one hilarious science adventure. You're going to want to see this. And there he is, our hero, Roboron, trying to measure a sports court with bananas. Yep, bananas. This one kind of ridiculous measurement is what starts our entire quest. And it brings up a great question. Why can't you measure things in bananas? And that, my friends, leads us to the first part of our mystery, the banana blunder. Let's dig into why Roboron's method, while definitely creative, is also a complete recipe for scientific disaster. So this really gets to the heart of the problem. On one side, you've got what we call non-standard units. Think bananas, or how many footsteps it takes to cross a room, or hand spans. They're easy to use in a pinch, sure, but they're also super inconsistent. My hand is a different size than your hand, and who even knows what counts as a standard banana, right? It just creates total confusion. But on the other side, we have standard units like the meter. The cool thing is, everyone, and I mean everyone, agrees on exactly how long a meter is. That makes it consistent and totally reliable.
Okay, so if bananas are a no-go, what's the big solution? Well, it's time to crack the code of standard units. This is like the universal language of measurement that helps our whole world make sense.
And here's the official name for it, the SI unit. It stands for System International. Basically, it's a worldwide agreement to use the same units for measuring stuff. That way, scientists and engineers in different countries can actually understand each other's work perfectly. Now, Roboron guessed it stood for Smart Intelligent, which is funny, but really, without SI units, your measurements would just be seriously inaccurate.
Let's look at the most common SI units for length, the ones you'll use all the time. The main one, our base unit, is the meter. When you're talking about really big distances, like a road trip, we use the kilometer. That's 1,000 meters. For smaller things, you've got the centimeter. There are 100 of those in a meter. And for teeny tiny details, you go down to the millimeter. The best part? It's all based on tens, hundreds, and thousands, which makes converting between them super easy.
So just how big can these numbers get? Well, Roboron did the math and realized his 5-kilometer trip to school is a massive 5 million millimeters. Whoa! It's the exact same distance, of course, but choosing the right unit, kilometers in this case, just makes life so much easier. And this is that big aha moment. This is how engineers can design everything from tiny little computer chips to enormous skyscrapers with perfect pinpoint accuracy. Okay, so now Inara and Roboron know which units to use. But knowing the units, that's just part one of the quest. Now it's time for the Master Measurer's Trials, where they have to learn the actual skills to measure things the right way.
And here they are, the 3 golden rules of measuring. You've got to remember these. First, you always start from the 0 mark on your ruler, not the edge. Second, you have to keep your ruler perfectly straight and right up against the thing you're measuring. No wobbles. And third, look straight down at the measurement. If you look from an angle, you can get something called parallax error, which messes everything up. They seem simple, but these rules are the difference between a wobbly shelf and a perfect project.
Of course, Roboron immediately tries to take a shortcut. He starts measuring from the 10-centimeter mark instead of 0. But his teacher, Madam Vidya, is on it. She knows that in science, there really are no shortcuts. You have to follow the rules every single time if you want a result you can actually trust. The next trial? Measuring a curvy wire. A stiff ruler is just not going to work here. So what do? You got to get creative. And this is where Inara shines. She just takes a flexible piece of string, traces the wire's curve perfectly, and then measures the straightened out string with a ruler. Brilliant. Problem solved. And Roboron? Well, he tried to use a piece of uncooked spaghetti. And you can probably guess what happened. It snapped. As he perfectly put it, his measurement was delicious, but totally inaccurate. This is the perfect example of why picking the right tool for the job is just as important as knowing the rules.
All right, we've totally mastered the art of measuring things. So it's time for the second half of our science quest, solving the great mystery of motion. What does it actually mean for something to be moving anyway?
So take a look at this bus. Simple question, right? Is it moving or is it just standing still? Well, the answer might actually surprise you. It depends. Yeah, really. It all comes down to your perspective, or what scientists call your reference point.
This right here is the secret sauce. A reference point is just a fixed object you use to compare things to. So think about it. If you're standing on the sidewalk as the bus goes by, that bus is definitely moving compared to you.
But if you're sitting on the bus, you don't feel like you're moving at all, right? You're still relative to the bus. But those trees outside, they sure look like they're flying by. So you see, motion is always relative to something else.
Okay, so now that we get that motion is all about your point of view, let's look at all the cool and different ways things can move. It's not just one thing. There are all these fascinating patterns to movement happening all around us all the time.
We're going to zoom in on 3 main types of motion you see every single day. That's linear, circular, and oscillatory motion. Let's break them down one by one.
First up, we've got linear motion. This one's super straightforward. It's just movement in a straight line. Think of a cricket ball rolling straight across the field, or a sprinter dashing down the track. It's all about getting from point A to point B in the most direct way possible.
Next is circular motion. And yeah, it's exactly what it sounds like. It's when an object moves in a circle around a central point. You see this everywhere. The blades on a fan, a Ferris wheel at a fair, the hands on a clock, even our planet going around the sun. The distance from the center always stays the same.
And then there's this really cool one, oscillatory motion. This is any kind of repetitive back and forth movement. A kid on a swing is a perfect example. Or a pendulum on an old clock. You can even do it right now. Just wave your hand back and forth. Or, as Roboron calls it, activating his robotic oscillation mode.
Okay, team, you've been listening, you've been learning, and now it's time to put that knowledge to the test. Welcome, everyone, to Measurement Madness. Let's see if you've got what it takes. Ready?
First question on the board. What is the SI unit of length? Ooh, Inara was quick on the buzzer with the right answer, the meter. Roboron, trying to be funny, yelled out banana before quickly correcting himself, but you know the answer. It is and always will be the meter.
And now for the final question, the big one. What is motion? This time, Inara and Roboron answered together, and they absolutely nailed it. Motion is a change in an object's position over time with respect to a reference point. That is a perfect definition.
And just like that, our quest is complete. We started this whole thing with a very confused robot and a kabaddi court full of bananas, and we ended it with a super clear understanding of measurement and motion. So what's the big takeaway here? It's that the world is just full of amazing things to figure out. So get out there, ask questions, stay curious, and keep exploring, 1 meter at a time.